Hello, good afternoon. I'm James Dyke, and it gives me great pleasure to welcome you to this GW4 panel discussion, You're Surrounded, ! Regionally led, globally relevant, nature-based solutions of water, where we will discuss water's relationship to efforts to address the climate and ecological emergency. Now, today's session format will be 3 short talks from researchers from GW4 universities, and then we will answer your questions and see where our discussion takes us. Okay, so what is GW4? Well, before we begin, a short message from our sponsors. The GW4 Climate Alliance is uniquely placed to address the global challenge of climate change due to its regional ecosystem and the complementary critical mass of expertise across the GW4 institutions of Bath, Bristol, Cardiff and Exeter University. In fact, it's likely that our Southwest region is home to more climate-related expertise than any other region worldwide. Indeed, the University of Exeter alone is home to the UK's top 5 most influential climate scientists in a recent list compiled by Reuters, and all 5 of those are members of the Global Systems Institute at the University of Exeter, of which I'm an assistant director. Now let's get some context for today's session. You may have heard about the International Energy Agency's new Net Zero by 2050 report. It was released today. It's been all over the news coverage. Now, among many things, this has really exploded the myth that we will be able to limit warming to no more than 1.5 degrees Celsius without really very radical action. It requires, for example, the almost immediate end of all fossil fuel investments and the rapid end of coal. But we know we will need to do much, much more. One of the greatest challenges we face is making these vast global scale scenarios and policies make sense down to where it matters, which is at the country, regional, county, city and community level. And that's what we're going to discuss today. We're going to have 3 presentations from our panelists that will consider how regionally based research can drive international progress on the climate and ecological emergency. And we'll also be able to reflect on the panelists' direct experiences and invite you to pose questions throughout. So who are these panelists? Well, today we're extremely fortunate to have Chris Clements from the University of Bristol, who will be talking about ecological crystal balls, can we predict the future? Jannis from the University of Bath, who will be speaking on polishing steps using wetland wastewater treatment, and Isabelle Durance from Cardiff University, who will be speaking on nature-based solutions for water security. Now, just to remind you, if you do have any questions, please post them. We will gather them and then put them to the panel at the end of their short presentations. And really, this is a space where we hope to curate a discussion. We can't be entirely sure where that discussion will go. We'll start with regional-based solutions and water, given that the Southwest is blessed with water. It's surrounded by water, and as you know, a lot of that water ends up on the land because it does rain an awful lot in the Southwest. But it's up to us what we make of this session, and I'm sure it's going to progress in a most fascinating ways. So, to kick us off, we're going to hear from the first speaker, Chris Clements, on ecological crystal balls. Can we predict the future? Over to you, Chris, please.
Thank you very much, James. Okay, so this is going to be a Petra Kuta style talk. So there's going to be quite a lot of information quite quickly. So apologies in advance, or this will keep you on your toes and hopefully wake you up after lunch. Can we do the first slide, please? Great. Okay, so the societies that we live in are dependent on the services that we get from healthy, functioning ecosystems. So James has been obviously talking about a lot about water, and that's the topic of this session. So if we're thinking about freshwater systems, we might be thinking about, say, food, clean drinking water. But as we start to degrade natural ecosystems, as we start to stress them, we start to remove some of those key links in those complex ecological webs. As we start to remove some of those links, we start to destabilize these complex systems upon which we depend for those key ecosystem functions. And this means that we're starting to lose resilience in these systems and at risk of losing those ecosystem functions. So if we think about a high resilience system, if that high resilience system is stressed, is disturbed, it will rapidly kind of fluctuate around and return to its original state. And that might be, say, a clear water system with clean drinking water. In a low resilience, degraded system, we might disturb that system again, but instead of staying in its original state, it might transition, say, to a algal-dominated, phytoplankton-dominated system where we start to lose some of those ecosystem functions. Oh, no slide transition. Can we take a next slide then on that? Something's gone wrong. Okay, great. So the Living Planet Index has recently shown that there's been a huge decline in global biodiversity, particularly in freshwater systems, an 84% decline in biodiversity since 1970. And a postdoc in my lab, Paul, has recently done an analysis which suggests that freshwater systems are also losing resilience faster than either marine or terrestrial systems. So what does this mean for the management of freshwater systems, particularly thinking about those ecosystem functions, and in the context of having multiple anthropogenic stresses, so climate change, eutrophication, and invasive alien species? Well, key to managing those systems is to have reliable predictive tools to understand what systems might change into the future. So how do we predict the future for ecological systems? Well, one method is to use mechanistic models. So here we build up a detailed mathematical model which has an understanding of all the different processes which are going on within that system. And you parameterize it and perturb it to see how that system might change into the future. The problem is those are expensive and time consuming. And a mechanistic model is what we call a process to pattern model. So you understand all the ecological processes and then you predict the patterns. Now the other option is a pattern to process model. So you look for patterns in data to infer changes in the processes that are governing how that system responds to future change. So what are these patterns that we're talking about? Well, high resilience systems typically return to their original state rapidly after a disturbance. Whereas in low resilience systems, we typically have a slower return to that original state. And the lower the resilience, the slower they return to that state. And this means that we get predictions like increasing variance in time series as a warning signal. So here we have two systems. We have a high resilience system and a low resilience system. You'll see in the low resilience, we have this increasing magnitude of these fluctuations. And if we say, look at the variance of this time series, we might see in the high resilience system very little change, whilst in the low resilience system, we have this increasing variance, which is indicative of loss of resilience. And that's what we call an early warning signal. They've been shown to be present in a number of experimental, theoretical, and real-world systems, and have been shown to be detectable before the collapse of populations, the collapse of ecosystems, and change in the state of ecosystems as well. So a regime shift from, say, clear water to phytoplankton dominated. So I have a PhD student, Duncan, who is currently compiling a database of different freshwater lakes from around the world. And he's interested to see whether we can use these predictive tools to predict these sudden changes in state in these big lakes, which provide those key ecosystem services that we talked about earlier. So we have three lakes that don't show any regime shifts, so they're kind of stable through time, and one which does, Lake Kinnerets, the Sea of Galilee. And this is a clear regime shift from low phytoplankton abundance to high phytoplankton abundance in about 1992. So we're interested in using this really nice long ecological time series where we have data before, during, and after this regime shift to see if we can predict that known regime shift. And he's been analysing this data and has been able to show that there are two distinct communities in the phytoplankton. So one pre-regime shift during the low biomass phase and one during the high biomass phase, so after that regime shift. So there's clearly a change in the state of this system. So can we detect these warning signals prior to this state change, which means that we could intervene? Well, no, it doesn't appear so. So these kind of classic early warning signals aren't present or not easily detectable prior to this regime shift, which is really worrying because this is about as good as ecological data ever gets, right? This is a 30-year time series monitored every month. And given that we know freshwater systems are losing resilience fast, that's really worrying. So this raises questions like, are we collecting maybe the wrong kinds of data? So are there other indicators of system health? We've previously shown that shifts in the body size of a population can be indicative of collapse in both whales and also in experimental systems that we've got in the lab. We might also start to think about changes in like behavior of groups, and maybe we can think about some alternative methods for predicting those changes. So my group's now really interested in trying to use laboratory systems to try and better understand and build predictive tools that we can use on those real-world systems. So we're currently developing small-scale experimental systems that we can print using 3D printers to make these complex, spatially explicit networks of patches, and then using things like machine learning to typify behavioral changes, trait changes, abundance changes for multiple interacting species, and then try and build predictive tools within the lab and start to think about how we might go out and actually apply those to real-world data sets, which is kind of the key link, right? And so if we're thinking about those key ecosystem functions and services, how best do we go about kind of predicting their future and managing those systems? Well, I think the key is to synthesize results and understanding from mathematical models, from laboratory systems, and also really link it to those long-term real-world data sets that we've got to try and build predictive tools to work across a whole suite of different ecological scales. And with that, I'll acknowledge and thank all of the people who've been involved with this research and the various funders, and also the University of Bristol. And thank you very much, James and GW4 for hosting me within this. And happy to take any questions, but I guess these are probably going to come through at the end, actually. Thank you very much. Apologies, that's so quick.
Many thanks, Chris. That was awesome. Yeah, as Chris said, if you do have any questions, please do put them in the chat, I guess. I think that's how we're collecting all the questions. And we need your questions because that's going to be the basis of our discussion after these 3 short talks finish. So let's go to Jannis Wenk from the University of Bath, polishing steps using wetland wastewater treatment. Over to you, Jannis.
Yeah, James, thank you very much for your introduction. Okay, can we start with the first slide, please? Yeah. Yeah. I don't have the slides here on my screen.
I think we can see them. It says polishing wetlands in the urban water cycle, and there's a little red circle around some grass.
Okay.
I think maybe you might need to do the pin the studio thing to the window. Maybe even make the window a bit larger. You might be able to see it.
Yeah. No, it doesn't. Sorry, there's an issue on my end here. Yeah, well, I'll do it with my own slides then. That's fine. So, okay, yeah, sorry for the delay. So I'm going to talk about constructed wetlands for polishing municipal wastewater. And the specific example we are doing is the Cromhall wetlands. You can see here 3 pictures. The middle one is actually our Cromhall wetland. So then we go to the next slide, please. Brief introduction on how are polishing wetlands used in the urban water cycle. Here on the left-hand side, we see a typical wastewater treatment plants. They usually do quite a good job. However, they have some issues in terms of removing nutrients, as well as trace contaminants and pathogens. So it is under the discussion to implement tertiary wastewater treatment for basically better removal. And there we have 3 options. We can, for example, use ozone or activated carbon, which are technological or engineered solutions, and there's also the option to implement treatment wetlands. The advantage of these treatment wetlands is that they are low energy. They have also additional usage, for example, as a recreational use in urban areas or as a wildlife habitat. At the same time, they can also be used as a carbon storage, and thereby lead to a further improvement of the water quality. Next slide, please. So the brief example I'm going to talk about are the Cromhall constructed wetlands. They're approximately 10 miles north of Bristol. And luckily, these Cromhall wetlands, they're full-scale polishing treatment wetlands, and we collaborate with a local water supplier, and they call it Wessex Water, and they're actually quite supportive of this project, and we've been collaborating with them just right from the beginning. Next slide. So here is a brief timeline on the constructed treatment wetland. The design started in 2015. Then there was some paperwork to do. There was official approval in 2017. And then in about 2019, the construction of the wetland started. We can see here it's a fairly substantial constructed wetland. It serves approximately a population equivalent of 4,000 people. Then we can see here in the fourth picture, during the construction stage, it looks all muddy, especially in the winter. But then after the plants were set, then we can see already that in August 2020, so last year, we had a fairly nice constructed wetland established. And also there is, since that time, then there's also research going on this wetland. Next slide, please. So what we do, we have basically 3 PhD students. They're working at different GW4 universities, and they're responsible to fully investigate and research this wetland. We have a PhD student looking at the biogeochemistry of the constructed wetland. We have an expert in analytical chemistry, and also we have an expert in molecular microbiology. So beyond the nutrients in the wetland, we also look at emerging contaminants, pesticides, pharmaceuticals, microplastics, and antimicrobial resistance. Next slide, please. Given the short amount of time, I cannot show a lot of the data, but basically I chose here one example from the wetland where we looked, for example, at the antibiotic resistance genes. The top graph here shows that the total microbial biomass, which is basically increasing along the wetland, that is something which is expected. But then here on the bottom, we have basically 4 different antimicrobial resistance genes. We see here the red circle shows basically the antimicrobial resistance genes output from the wastewater treatment plant. And then we see, like immediately in the constructed wetland, that we have in most cases a strong decrease. That is still a constructed wetland in the development stage, so we are continuing to monitor this, so there will be more results coming soon. Next slide, please. So here's just a few impressions of this wetland. You see here different plants settled. So we have here summer conditions. And also, last slide, please. Then we have here some nice winter conditions, and also the local wildlife has already accepted the constructed wetland. So with this, I'm at the end of my presentation. Thank you so much. So then apologies for the issues right in the beginning. Then back to James.
Many thanks, Jannis. I think you dealt with that superbly. It was seamless. Seamless. Okay, so without further ado, we'll go to our final speaker today, Isabelle Durance, Cardiff University, who will be speaking about nature-based solutions for water security. So over to you, Isabelle.
Thank you very much, James. So I'm going to be talking to you about nature-based solutions for water security. Next slide. Water security challenges are complex, they're pressing, and they're often intractable. The main water security challenges we face are around water quality, the fact that we have both persistent and emerging issues, for example, microplastics. Another challenge, which is really important, that Chris outlined, is a very rapid decline in freshwater biodiversity and their habitats. And that goes alongside other pressing issues, such as water scarcity, even here in the UK, with low river flows, and floods and other extreme events. The real challenge here is to be able to secure water for human well-being and prosperity while at the same time sustaining natural capital for future generations. And all of this amidst really uncertain social and natural changes. Next slide. So what can nature-based solutions for water provide? Nature-based solutions for water aren't a new idea. They have been implemented for some time. The idea here is to work with nature to improve the management of water resources, to achieve water security, and to contribute to core aspects of sustainable development. What that means is that the impact should be beneficial for society, for our economy, and for the environment. It's getting all of that to work together. And how do we do that? Well, when it comes down to water, this is about improving water availability, while at the same time improving water quality and reducing the risks to water-related extreme events. It's in fact about having a more holistic view of things so that the beneficiaries of water essentially are able to resource those that are helping to keep these water in the state that they should be. Next slide. So, for example, in Wales, Natural Resources Wales has had a look at all these nature-based interventions that have been happening across the country. And there are many of them, multiple interventions in lots of different localities. And these essentially come in two forms. There are either changes in the way we manage the land, for example, change in natural agricultural practices, or the way we manage our woodlands. But there are also infrastructure changes, the way we, for example, try and reconnect the floodplain with the river, or the type of infrastructure or soft infrastructure that Jannis was talking about. And all these multiple interventions happen across different scales, but they're mostly small scales, and they have multiple outputs and outcomes. Next slide, please. But where are the challenges? The challenges are multiple into implementing nature-based solutions for water security. One of the biggest issues, the challenges for decision makers is the scarcity of evidence for decision-making processes. It's very much trial and error at the moment. There aren't quite as many robust quantitative studies as we may hope for. There's not a huge amount of cost-benefit study. From a financial and technical perspective, there's still quite a lot of barriers, which means that these changes are quite small scale, and there isn't a huge amount of monitoring of the impacts. But probably the most difficult challenge is achieving a shared vision. So having a vision that works across the whole catchment, where upstream and downstream users meet at the same place, where users across different sectors, whether it's utilities, environmental agency, landowners, farmers, forest managers, river users, all get to agree about how to manage these fresh waters to provide water security. Next slide. So it's about working together, and in the southwest of the UK, we have brought together 4 big research-led universities with a range of partners, water utilities, the local water utilities, but also a range of partners and stakeholders that are all involved in the management of these landscapes. And together, 200 water researchers and more than 300 stakeholder partners, we're trying to make a difference by using these nature-based solutions to achieve a better outcome for water security. Next slide. And the way we can do that is because the union makes the force. Our complementary expertise and capability means that we can work together to develop the tools to measure and understand water across scales. We can better integrate the rural and the urban systems to manage freshwater quality and quantity. And we can bring all this data and models together to support the decision making. And this is particularly important when we are under uncertain change. Next slide. So what we're doing here in the Great West, as we call it, is build evidence and thinking to implement these nature-based solutions at scales. We're doing quite a lot of experiments, testing, for example, the impact of riparian buffers, this type of experimentations of how you modify freshwater ecosystems in the way that Chris was talking about. We work on assessing the effectiveness of these constructed wetlands. This is the type of work that Jannis was talking about. But we also work on develop the tools, the next generation tools to monitor the impact of nature-based solution interventions. And all that together is how we help to progress the thinking for nature-based solutions and assess the real multiple benefits of nature-based solutions. Next slide. And I think my parting words here are about the real success about nature-based solution is if we can work in partnership, and if we can achieve a shared vision, bringing together all different users in a catchment, the utilities, the environment agencies, the landowners, the river users, and the public. And there are such initiatives happening in our region because water is very important. We have forward-looking water utilities like Welsh Water or Wessex Water or Southwest Water in our region. And these are leading what we call upstream thinking, which is essentially looking at a catchment scale. Example here, the Brecon Beacons mega catchment, which is doing exactly that. Along with the utilities, along with the researchers, the environment agencies, the landowners, the farmers, the public, all of these are brought together to try and figure out what is it that we want to do with our catchments, how can we work together with nature, not against it, to create a better water security for all. Thank you.
Many thanks. Well, thank you to our speakers. What we're going to be able to do now is have a bit of a discussion, really, a bit of a kind of a panel discussion. That's going to be informed by the questions that our audience, our lovely audience, is providing us. But also it's a space where we can maybe have a bit more of a general chat about some of the things we've just heard, perhaps other issues related to the topic of nature-based solutions. So I'm going to kick us off. So I've got a question. So this is the best part of the being the chair. It means I get to throw questions and you've just got to answer them. So you're the boffins, you're the clever people, and you're going to tell me how we're going to fix all of this. So look, we're running up to COP26 in November. We're getting an increasing number of kind of scenario models that outline just the scale of the challenge that we face. Nature-based solutions, I'm sure, are going to be absolutely critical to us being able to avoid, climate breakdown and mitigate the worst aspects of this kind of ecological crisis that we're currently facing. And it makes so much sense, right? Nature-based solutions, they just seem to make an awful lot of sense. They almost seem common sense. Now, in order for that to happen, it has to be this kind of multidisciplinary, interdisciplinary or transdisciplinary activity. It has to be very kind of integrative, and it has to be cohesive, right? So why are we not doing this? Given how important it is, why do we not see more of these kind of approaches? I mean, we can start talking about in the context of water, nature-based solutions, but perhaps more generally, what's holding us back from doing more of the kind of work that we've just heard about? And I'm happy for anyone to jump in, and if there's no volunteers, I will pick on people. So what do we think? Or maybe reflect on the challenges that you might have faced in trying to progress some of this work. Who wants to get us started? Oh, I think Isabelle does, but she's currently on mute, so I'm going to...
Would you like me to start, James?
Go on, then.
Yeah, I think we are doing nature-based solutions, and I think we do have quite a lot of answers, even though these are mostly on a trial and error basis. I think funding is definitely, one big issue, but I really think that the biggest issue is getting people to agree about what to do next. That plus the fact, of course, that we don't really have a very good estimate of the costs and benefits of these nature-based solutions for now, and the more we can get to figure out and compare them with existing hard engineering solutions, the better.
So is that in the context of it's easier to measure the impact of pouring concrete, right? The problem is there's a flood, we pour a load of concrete, you make a wall, and it's easy to measure whether or not that worked, right? Whereas these more softer, diffuse interventions, it might be harder to get the metrics required. So maybe, I don't know, what do you think, Chris, in terms of our ability to collect data on the efficacy of these kind of solutions?
Yeah,
because it seems to require quite sophisticated modelling and data collection, doesn't it?
Yeah, I think Isabelle's right in that it takes a lot more time as well, right? If you're implementing a nature-based solution, you have to have time for that to mature. So things like rewilding on terrestrial systems is kind of being pushed widely at the moment. But it takes time. All of these things take time. It's much easier to pour concrete. You get a direct kind of measure of it. I think there's a huge amount of opportunities with advanced technologies to start to collect a lot more biological data than we have previously been able to do outside of kind of the realms of water, which is maybe one of the easier ones. It has been done for a lot longer in terms of more automated sampling. And also beyond LiDAR in forests, which is kind of the major push recently in terms of gathering kind of carbon sequestration data. But we're starting to now be able to kind of collect data from camera trapping and synthesize that from a huge suite of different kind of regions and types of data that we're collecting. And I think that synthesizing that alongside advances in modeling, so thinking about things like machine learning, where you can start to automate sampling from those, say, camera traps or videos of different areas, you start to be able to kind of build up a much more holistic picture of what you have in a habitat. And then you start to be able to kind of evidence how those systems are changing in line with, say, a nature-based solution. So I think it's kind of a rosy, there's an opportunity for a rosy kind of technologically driven advancement in how we kind of collect data more generally in biology, which is pretty exciting actually. And that gives me optimism rather than thinking kind of about some of the stuff I was talking about, having these huge long-term data sets and still not being able to do a very good job, at least with the methods, in fairness, very simplistic methods we're thinking about. Being able to do a really poor job, even with 30 years of data, is pretty damning evidence of our ability to predict the future. Yeah, but a slight detour, early warning signals are so alluring. I mean, I got involved, I jumped on that train a while because, wouldn't it be awesome for us to be able to get a heads up that there was some kind of regime shift or tipping point approaching? And yeah, certainly when you lose kind of paleoecological data or limnological data, you can be wise after the fact, but often you've got no idea whether it's happening or not. So Jannis, Chris just mentioned the issue of time, and at least there's the perception that traditional mitigation or adaptation measures are going to be faster, concrete sets in a couple of days or something. So when you're proposing these kind of nature-based water treatment works, do you ever have to work particularly hard to motivate or explain the timescale element? Because is there an assumption that these things are going to take years to spin up?
Yeah, with the constructed wetlands itself, it's in the initial stage, you actually have a lot of physical processes. So, for example, you have the adsorption capacity for phosphate removal, and that sets in immediately. So you see an immediate effect. But you also have long-term effects that, like basically the plants need time to grow, and so the biological community that still continues to mature. The constructed wetland itself, they're relatively well researched, so people know about the timescales that it takes, and it's not like we're not talking here about decades. It's more about, like, depending on what you're looking at, it's like month to year to 2 years, perhaps.
Mm-hmm.
So it's not awfully long.
Okay. And I've got to carry on.
Yeah, at least in these the engineered systems that are assumed to function in an engineered context. So we're not talking about like completely like growing a primary forest, for example, which would take hundreds of years.
Mm-hmm. Yeah. One of the attractions from a more nature-based solutions approach is that it produces multiple benefits. So, Isabelle talked about lots of different kind of you might want to call them co-benefits. Well, they could be considered as really, really important positive contributions in and of themselves. To what extent does that also represent a challenge when it comes to policymakers and regulatory authorities and agencies? Because you seem to be diffusing the potential benefits across multiple actors. If you're taking this kind of entire landscape scale approach, it might be harder to convince a particular agency to really get fully invested, or maybe even maybe some politicians. If you've got a politician with a particular constituency, they might not be very motivated about what's happening in a different constituency. So when we're dealing with multiple agencies and maybe even politicians in the political process, what kind of messages do you think work? How have we managed to get people to buy into the idea? What do we think?
It's always the same problem, is empowering people. And I think one of the difficulties is that, historically, landowners are the owners of the land. And I think the empowering comes from making people understand that are not necessarily landowners, that they also are empowered to do something. There are many citizen science type initiatives that are doing really well in terms of nature-based solutions, that are doing restoration work to reconnect the river with its floodplain, or to recreate ponds, and that is definitely empowering the public and getting the information out there, informing.
Mm-hmm. So again, there could be a really important part for the role of data collection and dissemination, right? So, and I would assume, I don't know, you need to correct me here, all three actually. I would assume that given the increasing urbanization that we see, most people are living in urban environments who might be very disconnected from what we might want to call nature. There just seems to be an important role for the demonstration and sometimes just a simple showing of what these kind of natural landscapes, natural systems do. Now, I know in the sustainability context, we're meant to talk about that using words like ecosystem services, water provisioning services and things like this, but these never really seem to, they don't inspire an awful lot of excitement. They're not really delivering on the tremendous value that these kind of natural systems produce, and also just how reliant we are on these kind of functioning ecosystems. I don't know if that's a question. It's more of an observation. I mean, do it.
Our urban areas are kind of depauperate from what you would expect if you went, say, looking somewhere like the New Forest, which is a mosaic landscape where there's plenty of biodiversity. But our urban centres also harbour way more biodiversity than most of our farmland, right? So we have higher pollinators numbers in people's gardens than we do in most agricultural land across the UK. So it's a bit of an interesting point, because our urban areas are actually quite biodiverse in a lot of ways, and there's certainly a lot more biodiverse than a lot of the farmland that we have. And our biodiversity is crushed into relatively small areas. I mean, the Lake District is pretty depauperate of biodiversity, so is Snowdonia, so the Scottish Highlands, because of agricultural practices largely. So getting people to recognise how much biodiversity is on their doorstep is probably a good start. Like, you can go into your garden, you can see a huge amount, especially during COVID. It's quite nice to kind of be able to go outside and see what is actually on your doorstep.
Mm-hmm.
actually just getting people to recognise that first. And I think, like Isabelle said, there's a huge amount of community work now going on to kind of rewild might not necessarily be the right word, but certainly spruce up biodiversity-wise a lot of our urban areas and a lot of our kind of not used green spaces. Which is a really positive thing to see, kind of communities getting behind that and trying to improve it for the future.
Yeah, so Jannis, one of the kind of the co-benefits of the water treatment that you were talking about was potentially significant increasing biodiversity, at least from the levels that it was at previously, right? So is that the kind of message that could motivate wider engagement and support?
Yeah, it's to have a more appealing landscape, but also like constructed wetlands. They're interesting as a bird habitat, and there's a great community, for example, in the UK. I did also research in the United States on constructed wetlands, and they were quite concerned for the opposite reason, because it can be also a place for mosquito breeding. Not so much an issue in the UK, but then in the US, basically the regulators, they said there must be fish in those constructed wetlands because they eat the mosquito larvae. So it can basically go in both directions. But if you address these, then also like educational tours are nice, and also if possible, having parts of the constructed wetland open to the public. And with wastewater, that is not so easy, but there's, for example, stormwater retention ponds. And they can be easily open partially to the public and can be also part of parks. So that is a good opportunity there to have the public engaged and thinking positive about nature-based solutions.
And what's the feeling for the sort of global potential for these sorts of nature-based water treatment schemes? Yes,
I think there is a great potential. Constructed wetlands are especially interesting for places where large areas are not an issue, because you need a certain area size for the treatment. If you think about like urban centers, then there might be like more technological solutions might be the better choice. But in countries such as Brazil, Australia, but also partially in India, constructed wetlands are very nice. Similarly in urban areas within the UK.
Okay, thanks. Okay, we've got a question here which is about essentially, okay, I'll just give you the question. So it's how do we convince upstream landowners to change practices and adopt nature-based solutions in order to benefit those often many miles away downstream? I think this kind of reflects on some of the comments we had earlier. Does that have to happen at the regional and national level, or can we take a more decentralised approach? What do we think?
I think this is something that actually is at catchment level, and I think that that is an advantage that anybody working with freshwaters knows, is that our boundaries are the catchments, and each catchment essentially is composed of smaller catchments, sub-catchments. So if we can work together at a catchment scale, then definitely we can make progress.
But we don't necessarily have the kind of the political structure at the catchment scale, do we? It's a bit more diffuse, isn't it?
It's true, but if we're working at a regional scale, like we are, for example, here in the Great West of the UK, yes, we can make things change.
That was a lovely answer. Thank you. I've got another question here from the audience. They're interested to understand what's the biggest barriers or maybe the greatest potential for the insurance sector. So I can imagine insurance industry being very interested in the implications of nature-based solutions. To the person who said it feels like a kind of a common sense approach for reducing potentially long-term risk. Has there been any interest from the insurance industry in any of this work in your experience? This could be a quick answer.
I work in a lab most of the time.
Well, I did. We had some entanglements with the insurance industry, but that was about early warning signals and game theory about how you might be able to incentivize people to collectively participate in group flood mitigation schemes, for example. And I do know from that the insurance industry is becoming increasingly interested, increasingly agitated, because you can see the potential liabilities coming downstream over the next few decades, and not even under the business as usual worst case scenarios, but it's going to be potentially going to cripple the industry if we don't get much more proactive about it. So I'm hopeful that you're going to see much more participation and also, maybe even direct funding and involvement in some of this research. I've got another question here. This one's to Jannis. Somebody's asked, are there any examples of constructed wetlands that have produced marketable products, thus promoting circular economy principles and offsetting some of the costs and risks associated with construction?
Oh, okay. I'm not sure about, and like if I know any examples, but marketable products, we have been publishing a review that looks basically at constructed wetland substrate. They're called light expanded clay aggregates. And that is basically like a product that can be used for constructed wetlands, but there is also now thoughts about like if that material could be also used after it has been spent in a constructed wetland, because it's usually good for about a decade, and then the phosphate absorption capacity is basically exhausted. But then, of course, it is full of phosphate, so it could be recycled. Another possible product is basically harvesting the reeds of a constructed wetland and having some added value use for them. So that's probably two examples I could think about now. But it's a very interesting question. I might think about it actually more.
Thanks. Okay, I've got a general question, or arguably a much broader question, not necessarily even related to nature-based solutions, and it kind of reflects on the appreciation that emerging climate research leaders are going to face very, very kind of complex challenges as we go forward. And that means necessarily engaging with people, within academia, certainly interdisciplinary research, but also, outside of the research world. So how do you think, from your own perspectives and experiences, we can kind of foster those skills? How can we develop these sort of climate research or climate and ecological research leaders of the future? Now, I have a suspicion that Isabelle might have some ideas about this, but I'll put this one to Chris first, right? So what would you give any early career researchers any particular advice, or maybe would you give some of the large funding organizations some advice about the kind of things that they should be prioritizing?
So I guess maybe it's a slightly cop-out answer, but I suspect that in the same way that not everyone who does research is a good teacher of, not everyone who does research is a good kind of communicator of that research. And so I think there are certainly a lot more opportunities for science communication now, and that does seem to be becoming a much more, universities are prioritising that as a course in and of itself. So I think the University of Bristol has recently, I think, done a master's, or was planning to do a master's on it. And so I think that remembering that if that is your forte, great, that's awesome. It's not for everyone. And to make sure that kind of, if that is what you want to do, that you're skilled in doing that, because there's probably nothing worse than someone who is a poor communicator trying to get across ideas and garbling them and confusing them. Then, yeah.
Have you encountered any particularly good opportunities to increase those kind of skills? I mean, either through your own training or through what other institutions or organizations are doing?
Not that I can think of off the top of my head. No, sorry. I'm blanking on that.
That's cool. All right. What do you think, Jannis?
No. Also, I'm not sure. Yeah.
Okay. I mean, we could consider it in the more kind of general context of how would we broadly empower, let's say, early career researchers? What kind of things could we be doing for them? Because they're going to be the new generation who are going to be developing these kind of nature-based solutions, right?
Yeah. I think one thing which I believe is important with the nature-based solutions is like I started relatively late. Like I was more or less interested in technical solutions, like for example ozonation and typical water treatment technologies. And then, if as an early career researcher, I would like try to find fairly established groups where you actually have access to constructed wetlands or nature-based solutions, or try to make these connections, because that really helps to go out of the lab and also have the infrastructure available where you can do the research. So that would be my advice if I'd start new, because for me it took very long time to gear up my research in that area.
Yeah, okay.
I guess one of the key skills is storytelling, right? And this is not just a theme for communicating science to non-scientists, but also a theme within science, is that often scientists are quite poor at telling a story. I always thought creative writing would be a really useful part of an undergraduate science degree, not actually, being able to tell a story. And at the end of the day, a paper or a conference paper or a note to a kind of someone in a position of a political position is all about how you weave that story and how you put it together. So I'm kind of quite a big advocate of trying to put in creative writing or some kind of something that's not directly science related, but actually would be massively useful for people in those positions. At an undergraduate level, that would be fantastic. Creative writing courses linked up with the English department or something would be a really novel way of kind of pushing those people who have got those interests and those skills to really develop it further.
Cool. I like that idea. What do you think, Isabelle?
Yeah, I think that, these are very complex challenges that we need to address, that the next generation needs to address. And I think to be able to address these very complex issues, yes, we need to, help train young early career researchers into one particular field so that they become very proficient in that field. But I think the more important probably is also that they can be T-shaped. They can get this broad understanding of the complexity of the challenges that we are really facing. And part of understanding that complexity is to be able to have the opportunity to work side by side with those that are facing these real world challenges on a daily basis, the practitioners, our stakeholders, water utilities. And I think that the more we can help our early careers to embed themselves in the real world, to go out there, to go on placements, to work alongside our stakeholder partners, the better it is. And we've got, in the Great West, we've got in the water domain, we've got 2 centres for doctoral training that do exactly that, where we have the supervisory teams of these PhD students comprising both a stakeholder and somebody from another discipline, to really make sure that happens. That next generation needs to have the breadth of tools and understanding to be able to tackle the type of challenges we have left them to deal with.
I think that's all awesome. And of course, GW4 is absolutely fabulous. But not all organisations really embrace that philosophy. I don't want to put you on the spot here, but, to what extent does UKRI really get that? Do you think they really understand the it's not a nice to have? And maybe in Chris's comments about, often outreach, engagement, communication. These are all sort of little bits of you put at the bottom of the CV as a little garnish or something, and increasingly it's absolutely fundamental. Do you think they really get it?
I think they are really getting it, actually, because I think our research, the UK research councils are working more and more hand in hand, and actually, they've got another name now, they call it UKRI, and I think that there is a real understanding, the 2 centres for doctoral training in water that we have here in the Great West are both funded by the research councils, and they are the ones who are promoting that engagement, and not just engagement with stakeholder partners, but that involvement of stakeholder partners in our training. And I think that is absolutely necessary to get us to the next step.
Yeah, I mean, so I lead a master's program, and even at the master's level on a sustainability program, I think it's absolutely fundamental that we get the students working with real world organizations and real world challenges, because the risk is you just mint a whole new cohort who haven't really contextualized their learning, haven't really been, confronted with a lot of the messy, complex, wicked challenges that working in this space kind of necessarily throws up. We have a specific question for you, Chris. And so they're asking, according to your slide, freshwater systems are losing resilience faster than marine or terrestrial, and yet the UN has just declared a decade of the oceans. Are we prioritising wrongly, is the question.
You're allowed to say yes, Chris.
Carefully. I mean, prioritising wrongly, or... I don't know if I'm going to answer that directly. I think the freshwater systems certainly bear looking at closely, given that they, for a lot of places, provide a huge amount of freshwater food, particularly for potentially some of the places that are a little bit have less money to spend on some of the solutions that would give them the freshwater and food. So I think potentially outside of the kind of more westernized countries, then maybe we are prioritising slightly wrongly. But the kind of sad fact is that whilst freshwater systems are doing badly, it's sort of everywhere else as well. So it's not kind of a, hopefully it's not an if or, it's an and. We should be prioritising all biodiversity and trying to do as much as we can everywhere. And hopefully there are some signs that there's kind of change in the way people are thinking, this big push towards rewilding. Not that that's necessarily the solution to our problems, but seems to be a kind of global movement to think more about the environment and about hopefully some positive feedbacks that actually self-propagate after a while. So some of these nature-based solutions, I guess the ideas behind them is such that you're not having to do something and then maintain it. You're having to do something that will continue to have more and more positive effects the longer you leave them. And so, I've kind of dodged that question. Apologies.
Well, we're not going to let you get away with that, Chris. So let me have another go. You started off with regime shifts in freshwater systems, lake ecosystems, so they can undergo a transition from this kind of clear state to very turbid, murky, algal state within a matter of days, right?
Yeah, very quick.
Whereas we know there are tipping points in the Earth's climate system, the AMOC, the Atlantic Meridional overturning circulation, the Greenland ice sheet was in the news again this week. But there's the assumption that these things are going to operate over much longer timescales, right? So even though they might be more important for the climate function, the things that are going to be happening maybe in timescales of weeks would be those kind of freshwater ecosystems. So perhaps we could make the case that we can't ignore these much faster acting kind of ecosystem, which, and then, as you said, in a developing or a less developed nation context, these freshwater ecosystems are absolutely critical, aren't they, right? For not just fresh water, but for food.
Yeah, absolutely. They're also the things that we can probably do most about, right? It's really hard to do something about global climate tipping points, but it is fundamentally possible to do something about a freshwater ecosystem where, as you say, you have a catchment which is defined, right? You can measure what's going into a lake and, okay, there's going to be effects of climate change and those are going to be much harder to deal with. And multiple stresses are a big issue. It's one of the things my lab works on, is to try and understand what the effects of more than one stressor simultaneously on a system is. And the spoiler is that it's almost always bad, right? Being affected by climate change and eutrophication is pretty much always worse than being affected by just climate change.
Yeah.
But a lot of those things are, manageable. You can manage invasive species, you can manage eutrophication. And the reason that freshwater lakes are at risk is because they have a clearly defined area, right? They're relatively closed systems compared to something like the oceans. In an ocean, you have an opportunity to move with climatic change. You don't have that option if you're a lake-dwelling organism. So yeah, there is, yes, we need to manage freshwater systems, particularly where they're providing services. They are also probably the things that are some of the best monitored in the world. So that's not a new concept, right? We have data going back 100 years on various lakes around the world in terms of the phytoplankton, because ecologists have always been interested in the stuff that's kind of close by and that we know is important. So you would hope that with all that data, we would do a better job of modeling. As you said, the early warning signals are that kind of that halcyon thing that never quite happened, you know. It would be great if they did work, but all the research that we've done seems to suggest that they're in the real world, they're pretty useless. So looking for some alternative methods that might supplement things like mechanistic modelling and a deep understanding of what's going on in the system is important. I mean, even if we have some of a hint of what might happen into the future, it gives us opportunity to prioritise. We have kind of the cliche that we have limited resources and that we need to prioritise what systems need to be looked at first is a cliche that is true. So anything that we can use to kind of help us determine what systems are most at risk and then kind of level down and then do more work and research is always going to be useful, I think.
I really do feel like I missed the boat with the whole early warning signal stuff, because the first guys, and it usually was guys, you know, Dakos and Carpenter, who did all the work and developing all the tools, and they had all these papers in Nature which said, look, we can develop all these methodologies that will detect early warning signals of impending collapse. And then 10 years later, when we've all realised that doesn't work, they get to do a whole load of papers saying, look, that doesn't work. So they get it on the way up and they get it on the way down. Not that I'm bitter. Okay, we've got another question. This one's to Isabelle and Jannis, actually. So you both seem to be working with a large number of stakeholders outside of academia. So the question is, how do you manage the expectations of potentially very different partners? You know, so you've got companies, local governments, maybe local community groups, individual residents or something. How is there a methodology you use, or have you kind of made this up as you've gone along in a rather more agile approach, let's say? Maybe Jannis, what do you think?
Yeah, I mean, I don't work like in most cases I work with separate partners. So there is like usually it's like a one-to-one expectation management. So, and I usually have like I have a small number of partners to work with, and we have a relatively close relationship. So that is also part of my character, because I need some time to build trust to people as well. So I have people at Wessex Water I have been working with like for some time now, and then the trust actually builds with them. So that is more like, it's more like my subjective approach. I think Isabelle, she really works with larger groups, so I'll pass that question on to her.
Very deftly done. Isabelle, what do you think?
Well, I think it's really interesting, because I think universities, research organizations, but more so universities who work regionally like ours, we are in a very interesting position that we have a citizenship role to play, and we have I think a really interesting opportunity to act as brokers, to be that neutral body that we don't have any vested interest in one part of the landscape or another. We are science and evidence led, and that's a consequence, I think, that we are absolutely ideally placed to be able to play that brokering role where we can help stakeholders who actually might end up, wanting the same thing, but get the conversations going, get the discussions going, getting people to work in synchrony. Because very often what happens is that, you get a small association doing something here, and then another associations are doing something somewhere else. And I think one of the things that we have discovered over the past 20 years is that freshwaters are under a range of pressures, and just taking one pressure off isn't enough if we're doing it in one pressure at a time. So we really need to work in synchrony and across sectors. And to be able to do that, I think, going back to the upstream, downstream question also, I really think that universities, especially regionally embedded universities like ours, are in a really fantastic position and potentially a responsibility to do that partnering job.
Okay, great. That's wonderful. We have 10 minutes exactly left. So I want to, there might be some additional questions that come through, but I want to be able to pose what could be a kind of a final question and a sort of an opportunity to do a bit of summary to you all. I'm going to present it like this. Imagine it's the 12th of November, probably very, very late at night, and Alok Sharma is just about to bring COP26 to an end. So UK, as we know, will be hosting the next conference of the parties in Glasgow. Well, we hope. I mean, COVID willing, it's going to be an in-person COP. There is tremendous pressure building up to this event because we need to do something quite transformative in terms of countries' nationally determined contributions. There's going to have to be a really large ramp up in ambition on action on the climate. And I know some people are very concerned about the potential, if we don't do this right, devastating impacts on biodiversity. For example, bioenergy could, increase rates of deforestation. And also there might be some, real impacts on marine and freshwater ecosystems. So what I want to ask you all is I want you to imagine that Sharma's just brought COP26 to a close. And what would success for water and maybe more generally nature-based solutions look like? What kind of things would you hope to see agreed at COP26, or maybe what kind of things would you hope would not be agreed, if you want to give it a more kind of a negative framing, and what would success look like? Who wants to take that one? Chris.
Pick the person who doesn't work that much on nature-based solutions. That's going to be really difficult for me to answer. Can I do that one at the end, please?
Go on then. You can do your homework whilst Jannis has a go at it.
Yeah, I mean, that's a very difficult question overarching question, but I think for water or for aqueous ecosystems or terrestrial ecosystems, I believe more or better solutions for sustainable agricultural business. I think that really one big issue is fertilizer overload and the continuous use of harmful pesticides that basically lead to the degradation of biodiversity. So I think my wish would be really like for more sustainable agriculture, because a lot of the environmental issues that we see stem from that area.
Mm-hmm. Well, okay, here's a route in then, Chris, because you know that a lot of eutrophication will be driven by agricultural effluent. One of the drivers of that is increased intensification in agriculture. And one potential driver of that is going to be the increased use of land for energy crops. So we need to, we call it sustainable intensification, or, climate unicorns or magical thinking. We're going to grow more food from less land, but with fewer impacts. So somehow we're going to reduce, because it is the case that, phosphorus runoff is one of the big drivers of eutrophication or something. So, is that something that needs to be acknowledged at these kind of big global climate meetings, the kind of the inadvertent or the byproducts that trying to tackle just one element of a climate and ecological emergency might have on wider ecosystem function?
Yeah, this is getting towards the kind of land sparing versus land sharing ideas, right?
Yeah.
We intensely hit one area, and as far as I know, the research in that suggests that it's better to really blitz one area and then spare the other areas. And that's not kind of been historically how we've thought about it, right? We've just historically kind of tried to spread out and have fewer impacts. But yeah, I think the multiple stressors and the kind of how eutrophication and other stresses interact to have consequences downstream is probably the biggest threat to biodiversity at the moment, and we still have a really poor understanding of how that will impact biodiversity. So kind of getting a handle on how those will interact and how those affect biodiversity and how those kind of break apart the positive feedback loops that you would hope that some of these measures will start to have to kind of propagate positive interactions is really kind of critical to understand.
Obviously important role for modelling. Are there any immediate data collection gaps that you think? Any kind of new programs that should be implemented?
Good question. So I think this is not particularly new, but I suspect LiDAR will play a massive role in this because we can really quickly kind of typify large areas of the UK and start to think about things like structure, and we can start to link structure to function. Particularly important because we can do that for things like riparian habitats, and we can do that for whole catchments simultaneously. And there I think there's a big role to play in how we kind of communicate develop or redevelopment of currently depauperate areas to have those positive feedback loops downstream. So things like Jannis is working on, that's a constructed wetland for a very specific purpose, but thinking about introducing beavers, for instance, has a very similar effect for getting rid of nutrients in a kind of much more simple way and cheaper way through a kind of semi-natural ecosystem. So there's a huge opportunity for kind of, like you say, a more holistic approach across multiple different landscapes. And that is going to be tied to biodiversity. So really thinking about beyond what you just need to get out of it, but for all the indirect ways in which those ends are met.
Okay, great. And so finally, Isabelle, what does success look like to you?
Well, I think one of the things that this pandemic has shown us is the importance of nature and also the opportunity to change the way that we currently do things. And I think that, the blue-green recovery is definitely an agenda that everybody wants to go to. And that works with, a mixture of carrots and sticks. So additional funding opportunities, incentives to be able to reduce those pressures, increase those nature-based solutions, increase the protections to freshwaters. But it also means, a change in policy, the right regulation that it is a form of incentive in that you have to regulate those pressures, and the more there is an accepted way of doing that, the more everybody will work towards it. And I think, that the big change here is that we've always worked against nature, putting dams, stopping things from going where they shouldn't be, and particularly for water, trying to put water where it isn't and trying to stop water going where we don't want it to go. And I think, in these uncertain times with the climatic changes that we will see, even if we manage to get our temperatures above the under those 1.5 degrees, I think we need to learn to live with uncertainty. It's a bit like the pandemic. What we have learned is that uncertainty is something that we need to live with, and I think that when it comes to nature, I think we need to accept it. We need to work increasingly with nature because that is the only sustainable way to do it, because nature repairs itself, restores itself, and can continue forever, whereas every kind of engineering method that we would throw at it is bound to have a very limited time life. So I think my takeaway message from what has been happening these past months is that we need to work with nature and we need to work together.
I think that's a great concluding statement for what I hope has been, I hope everyone has enjoyed this session as much as I have. Thank you so much. I mean, just a simple message of, let nature heal itself. It's been doing it for billions of years. But just let me thank the audience for your wonderful questions and participation today. Many thanks again, Chris Clements, University of Bristol, Jannis, Wenk, University of Bath, and Isabelle, Durance, Cardiff University. Thanks so much for your time. I'm sure we could continue this discussion. If we were in a real world conference, we'd be off to the pub. So we'll just have to imagine we're going to continue these discussions over a pint or a glass or two of wine. But that's it for us. Thank you very much. Thank you.
Thank you.
Thanks very much, James.
Cheers.
Cheers.
Thank you.